Okay, let's give you guys some more practice. So let's say you've got a jet fighter here flying through at an altitude of 6,000 meters. So by the time, well, when the jet fighter's here, this is our radar here. We're able to detect this plane. So when it's here, we're already keeping track of it. So by the time it gets to here, because we've been keeping track of it, we know our angular speed here will be given by pi over 180. Um, and then at this precise moment in time, the angle here is pi over 6. Okay, so given this, work out the speed, work out the speed of the jet at this precise moment in time. Okay, so if you call this here x, if you call this here x here, so it's me asking you to find out. Well, me asking you to find out the speed of the jet is like me asking you to find dx by dt. Okay, so this is your right angle, blah blah blah. Find the speed of the jet at this precise moment in time. Okay, so remember, at this precise moment in time, it makes an angle of pi over 6. Anyway, find the speed of the jet. Press pause and have a go. Okay, so to do this here, if you look at this here, it is the dx by dt that we want to know. We've been given the theta by dt. Um, so looking at this here, we've been given this, and it's this that we want to know. So we've got to find out. We've got to find something that connects theta and x. The thing that will connect theta and x will be tan. So the thing that will connect theta and x will be tan. Okay, so if you tan the angle, it will be 6,000 over x. Okay, so this is the thing that connects theta and x. Okay, so from here, oh, bear in mind what's going on as well. So as the try and understand what's going on here, because as the plane is flying through here, so over a period of time, you see theta here. Over time, theta is a function of time. Now, and then if we call this x here, as time goes by, x is also a function of time. So when you're here and when you are here and then you use implicit differentiation, that will then take you to here. But then so when you differentiate tan theta, it will give you this. Okay, this is something that you have to know already. So when you differentiate this, it will give you 1 over cos squared theta. But the thing is, because theta is a function of time, we need to stick this in here. And again, when you differentiate this, it will give you this. But because x is a function of time, we need to stick this in here. So it is tan that connects theta and x together. But then use implicit differentiation, that will then take you to here. Okay. So when you are here, you need to know x. You need to know when you are here, at this, when you are there, at this precise moment in time, as opposed to over here, at this precise moment in time, right here, the angle here will be pi over 6. We need to know this x here at this precise moment in time. You see, at this precise moment in time, we need to know this x here. Okay, so hang on. So it is tan theta that connects everything. Use implicit differentiation, that will then take you to this. And then now, at that precise moment in time, we need to know x here. We need to put an x into here. So we need to find x. So at that precise moment in time, hang on. At this precise moment in time, this will be 6,000. At that precise moment in time, the angle here will be pi over 6. So now we can work out x. So tan this angle here, which is pi over 6, equals 6,000 over x. So now we can just rearrange it to work out x. Okay, so we are currently here, but then we need to know x at that precise moment in time. So we need to basically solve this, blah blah blah. So x at that precise moment in time, x will be this. Okay, so now we need to put this into here. So if you look at this, you've got minus 6,000 over x squared. So over this thing here. Okay, but the thing is, you got this thing divided by this thing here. So visualize this whole thing here as this negative 6,000 divided by that fraction here. So now when you divide a fraction, you times by the reciprocal. So this we simplify with this, blah blah blah. Tidy up, it will then give you this. Okay, and then don't forget it is this that we want to know. And also we need to know theta at that precise moment in time. Well, theta at that precise moment in time is pi over 6. Okay, so hang on, bear with me. So at that precise moment in time, hang on. At this precise moment in time, theta will be pi over 6. Okay, so at this precise moment in time, theta will be pi over 6. So hang on, back to here. So um, at this precise moment, well, don't forget when we were here, we need to know theta at that precise moment in time. So at that precise moment in time, theta will be pi over 6. Okay, so now we are here. So now we want to get this on its own. So divide both sides by this thing here. So dx by dt is given by this. So now times the reciprocal of this. So that will then give you this, and then tidy up. It will then give you this. So dx by dt will be given by that. Jump to a calculator, and the speed of the plane will be negative. Well, this is really the direction. This negative here is the direction. The speed here will be given by 418.88 meters per second. Okay, this negative here is really because hang on, it's because of this here. We've taken this to be x here. So x is positive in this direction, but because the plane is going in this direction, that negative indicates that it's going to the left. Okay. Well, anyway, the answer is whatever was earlier. Okay.